Service Logic, we believe the future of the skilled trades lies in training and development, and that's why we created the Edge, a platform dedicated to empowering our greatest assets, our people. From hands-on training to leadership development, Edge is where technicians grow their skills, expand their opportunities, and build lasting careers. Because when people succeed, our companies, our customers, and our industry thrive. This is the Edge. This is the future of the skilled trades.
I chose iConnect training equipment because I already previously had some iConnect training equipment. And I was very pleased with the equipment I had, the quality of it, and pre-designed labs that came with it. So when I expanded it more into the catalog, I decided I wanted to get this refrigeration trainer in my program to expand my program. My experience so far using the TU-155 has been a pretty good experience, especially my second year students. And it the light bulb kind of syndrome goes off when you see that little flicker in their eye and they're, oh, I got it. That's what us instructors, what we look for is the I got it moment. And this helps me to the I got it moment with my students, and that's what's my goal to achieve.
We are Daikin, the #1 global indoor comfort provider. Our innovative home and building solutions are engineered with energy efficiency and sustainability at their core, ensuring improved indoor air quality for all. From heating and cooling to ventilation, air purification, refrigeration technologies, and connected devices, we're at the forefront of technology, addressing the pressing challenges of sustainability.
Hello, everyone. Thank you so much for joining us once again on Did You Know, the ESCO HVAC show. We are going to have a fantastic time today. We have a really fun and enjoyable electrical meter. It's going to be presentation, but it's going to be hands-on as well. So we're being joined by our good friend, Louise Kellar from UEI. How are you today?
Oh, I'm doing great. How about yourself?
I'm doing fine. Getting everything set up here in the studio. I just got some UEI meters set up. We're going to jump over there here in just a minute. And the newest member of the HVAC Excellence ESCO family, Todd Clare, who's going to be joining us as part of the Visual 3D Academy venture. How's it going, Todd?
It's going great. Going really well. And don't forget not to take your thunder, but don't forget to tune in on Tuesday for our first airing.
That's exactly right. So we're actually going to be launching a second live show podcast that's going to be diving into the Visual 3D Academy world. And we hope that everyone joins us and checks that out and learns a little bit more about this exciting new component of the ESCO family. All right, Louise, I'm going to go ahead. I think I'm actually going to start migrating over. Maybe we'll come back to do some presentation if we get to that point, if we run out of time. And everyone, let us know where you're joining from. I'm hanging out in the mobile studio. I actually just got back yesterday, went down to the Kentucky Derby. I was invited by the UA 502. It was a fantastic experience. We were part of the tailgating party that they had before the bed races, which was insane. And then we got hit by a major storm. And yeah, it was a lot. Peter, hey, thanks for joining us today. Glad that you're hanging out with us. So, Louise, where are you joining from?
I am joining from my natural habitat, also known as my own house today. So if you didn't know, I do like a lot of plants. I like that fresh air that they create around me. They make me happy. But that is where I get to go. But I did get to take a scenic detour today. Just so everyone knows, I got to see Clifton for a little bit this afternoon, and we took a scenic tour of the Cracker Barrel parking lot today. So yeah, they even let me outside in the fresh sunlight periodically.
And Todd, where are you joining us from today?
Good old sunny Southern California, city of Menifee.
Absolutely. So what Luis was talking about, we're actually going to introduce one of the new meters today. We're actually going to spend a little bit of time talking about a few different meters, but this one in particular, this is the new UEI HAC, which, Luis, what does that stand for?
High accuracy clamp meter.
I like it. Right.
Yeah.
We're going to look at, how these new meters and new test instruments are changing the way HVAC looks at precision. When we get into working with some of these advanced pieces of equipment and technology, many of them require us to start looking closer at our tools. And that's really what today is about, is looking at some of the newer functions that you'll see on multimeters and helping you understand, hey, $5.99, that's a great meter.
It is.
Yeah, good job. So Osvaldo joins us all the time, Luis, from Belize, South America.
Oh, fantastic.
So a technician that is just growing by leaps and bounds because he's learning from educators like yourself. So I'm going to go ahead and move over. Hey, Mr. Harrell, how are you? I'm going to head on over to the trainers, and we're going to talk about a couple of things. So let me pull this one back. And Luis, let's talk a little bit about power factoring before we go over there.
Yeah. So this is one of the features that is on that new HAC meter, is the fact that it does power factor and watts, and you can see it easily on your screen. But what is power factor? Because I think it's easily confused.
Absolutely.
So the analogy that I like to use is, imagine if I go to a restaurant and I purchase a glass of root beer that you see over there on the left-hand side of the screen.
Or lager.
So we're going with its root beer, okay?
Root beer.
I'm going with root beer. So that root beer, though, there's two components in that glass. There is the actual root beer, and there is that foam, that fizz, that carbonation on the top of it. And no matter how much foam or fizz is on the top of it, I still pay the same price for that glass of root beer, right? And so that full glass of root beer is the apparent power, and that's the amount of power that's actually coming in.
Total input.
Total. Exactly. But the problem is that there's not all of that energy is actually used. So there's what they call reactive power. And so that's kind of the power. It doesn't really seem to do a whole lot. Like, there's an important reason it's there, but it's really not contributing to the overall power consumption. So the real power, the power that's really working for you, that is going to be the actual root beer that is in that glass.
Makes sense.
Yeah. And there's a formula, so you can see on the screen that, the power factor, it's the watts divided by the volts times amps. But we're not really going to get right into that one. It's much easier if you have a meter that will calculate that out for you.
Okay. I'm digging it. So Todd, you and I grew up in a world of meters that didn't have nice, fancy things like this. So
analog meters.
Yeah, even you and I have.
You want to see that little needle moving?
Yes, absolutely. I don't have any in the studio, but I probably need to add some. I'm going to change mic so I can go remote. How's audio? Is it coming through okay?
Yep.
All right. So I'm going to head on over, and we're going to spend a little bit of time just talking about how these meters change the way we look at systems and the efficiency of systems. So we're actually going to work with a few today. I've got my old trusty DL40, which, for those of you who haven't been on the show when I've talked about it before, this is my original meter. So when I got into the industry, this is where I started, and it is still a fully functioning meter. I've lost a lot of the spring tension of the clamp because it's been used who knows how many thousands of times, but it is still a fully functioning meter. And at the time, I felt like it was a pretty advanced meter for what I did. I mean, it measured amps and it could measure resistance. It had DC, but it's only 4-volt DC. So for those of you that like working on other things like automobiles, it kind of limited me on working on automobiles. So it mainly was my HVAC meter. Now, Osvaldo, you mentioned that you had that 599. So I've got the DL579T, which it also has some of the functions we'll talk about today. But Luis just got me today the new HAC, which when we start looking at this high accuracy clamp meter, it helps us re-look at meters in general and functionality of meters and how we can have disturbances that can change the way that our meters actually read. So we're going to fire some things up. This is just my plain old 80%. This is actually an 80% Goodman furnace. I put this thing back together in like 2018. It's been a very useful item. But we're going to look at a couple of things. So we're actually going to use the HAC, even on this little stack motor or watt motor, we'll sometimes call them. We're actually going to use our high accuracy meter, and we're going to look at some wattage and some power factor. So Luis, let me actually pull into second view. I'm going to fire this thing up.
Fanciness.
Now, let's walk through a couple things here. Walk me through this meter as far as looking at our power factor, looking at our wattage. Where's our primary function on this?
So you're actually, when you look at the dial of the meter, you're going to notice that when you go over to the volts, just to the left of it in red, you'll see the power factor and the watts.
Okay.
And that is an indication. So if it's in white on the face of our meter on that particular one, that's the default mode. So turn it to volts, and then you'll see that there's a red select button on your meter that you'll have to press and hold. And that red color coordinates to the functionality that you'll see on your screen. And then once you press and hold it long enough, you'll actually see that your display screen will now suddenly start saying PF on one line and W on the other. So it's going to give you the power factor and the watts. Oh, Clifton, I think we lost some of your volume.
You did?
Oh, now you're back. Oh, you're gone again.
Let me go check my audio signal real quick. Is it still low? How's that?
Nope, we're good now.
Yeah, that's interesting. I don't know if I had some interference from something. Okay, so I'm going to show everyone the backlight feature on their meter. Not everyone is aware of the backlight. On this particular one, our hold button, which is on the side of the meter, is actually a backlight function as well. So if we hold that in for a couple seconds, we're going to get a backlight on our meter. So here is that red select that Luis is talking about, where it's going to change it from the white settings to the red settings. Okay, so I have now moved over into my wattage power factor. So, Luis, let's talk about how we measure wattage. Let's start there so that we understand where our meter is going to be connected.
Yeah. So watts for just the definition of it is it's your amps times your volts. So you're going to want to get your amp draw. Yep. So that's going to come through your amp clamp. Exactly.
So we've clamped onto a primary lead of our motor in this case.
Yep. And then we're also going to want to be able to test our volts at the same time.
Okay.
So with your test leads, yep. Go ahead.
For this scenario, I've actually went back to my main board, and the two power wires for our fan motor are right here on the fans tap and then over on common. So these two leads I have connected on. So we're reading voltage here and we're reading amperage here. So as you can see right now, we're actually not reading anything at all. Are we ready to fire this up, you think?
I think so.
Okay, so I'm just simply going to go over to my thermostat. I'm going to turn the fan on and we're going to fire this thing up. Okay. So when I look at my two numbers here, what am I actually reading?
Okay, so the one number that you're seeing that is your watts, that's going to be your energy consumption. So when we start thinking about things like when you get your utility bill, your electrical bill, right? They bill you in kilowatts per hour. So it's
Yes.
really telling you how much it is going to pull and affect your utility bill. But
So
the
we're
power
currently
factor,
drawing
yep.
28 watts. And then what is on the top number?
So that top number is actually your power factor. And so power factor is basically it's a percentage, and it's telling you how efficiently it is actually using that wattage.
You mean this
So I
shaded pole motor is only like 30% efficient?
mean, it's highly possible.
It's about right, actually. So our shaded pole motors are very inefficient. And so for those instructors that are with us, this is a fantastic way to show different motor efficiencies, because we can actually look at the true wattage draw of that motor, and then we can start looking at those power factors, and we can see the efficiencies that change through those. So I really like being able to do that. Like you said, Louise, when we start looking at the efficiency of a system, we're going to see the day, and actually maybe much sooner than most realize, if you're going to do an installation of a heat pump and you're looking for a rebate from a local utility, they're going to require a commissioning report. And that's the things that they want to see. They want to know, what is the efficiency of this? Because if I add poor ductwork onto this thing and I slow this motor down, ooh, we'll see. I'll see if I have enough time to connect to it. I actually, on one of our other trainers, I've got an adjustable duct supply that I can put that. I'm going to add a little resistance to this thing.
All right.
Okay. Maybe. Hold on. Be safe in doing so. All right.
Correct.
So we're going to add a little resistance to our motor and see if our watts are already changing. So on a ducted system, we can actually show the variations of poor ductwork on the performance and efficiencies of the motor with a very simple setting on our meters. That's kind of fun, actually. What do you think?
Oh, it's super fun. Because ideally, I mean, if we lived in an absolute perfect world, that number would really be 1 on your power factor.
Right.
But because we don't live in a perfect world, generally, though, we would hopefully see a little bit higher numbers than the 0.3 that you're seeing on that screen today.
They are very inefficient. So
yes.
I'm not too surprised to see it that low. As we start increasing our motor efficiency, we'll see drastic differences. We'll start getting up into the 70s and 80s. But that's the reason those shaded pole stacks actually get warm. Like this motor right now is actually warmed up significantly because of the inefficiency of a shaded pole. And it doesn't even have ball bearings on this one. It's got sleeve bearings, so they could even be dry from hanging. The oil could have ran out of them, and that motor may be performing extra inefficient. So, yeah, really cool one. Okay, so I've got another one I wanted us to talk about.
All right.
Another good point that you brought up was when we're talking about ghost voltages and how we can actually measure and hopefully eliminate some of those ghost voltages. How are we in frame? My poor thing is...
We're giving it a workout today.
Yeah, we go. Well, I think I had it on auto tracking. I need to add me a separate monitor over here so I can see exactly where we are. Are we in full screen now?
You are in full screen. We're seeing both of the setups you have going on.
Absolutely. All right. So what we're going to do is from here, I want to be able to show you exactly what I'm looking at. With our previous generations of meters, we could actually detect voltages that we couldn't always explain. And so a lot of people call those ghost voltages. Todd, you ever encountered ghost voltages before?
I think we may have lost Todd.
Yeah,
oh,
I'm
there
here.
he is.
Okay. So yes, I have experienced that.
It's
rare.
Picking up very sometimes rare, but sometimes you'll get voltages and you're not sure where they're coming from.
And they're hard to find.
So we're actually going to show you, particularly for instructors, how to show ghost voltages in the classroom, and then how to show how the modern meter can actually eliminate that. So on this particular one, we're going to use this 579. I'm going to put it just on standard volts. Let me get a backlight for you. Now, what we're going to do is we're going to talk about electrical induction. So typically what we find when we're getting our ghost voltages or stray voltages, it's when we have wiring, particularly if it's a low voltage circuit that is running next to a high voltage circuit. And if we have any coiled wire, like sometimes happens when we get wires bundled up and tucked in places, we can actually induce voltages onto conductors, even though they're not touching by their internal leads, by the
You
copper.
mean EMF?
Exactly. So tell us a little bit about that, Todd, while I'm putting
Electric
this
motive
in.
force. I think Louise could tell us a little more about it than I can, but
Okay,
you know,
either one of you.
I mean, we do the same thing when we do old thermostats, right? And we wanted to measure it, so we'd wrap around 10 times and we divide it by 10, so we get that in the amperage of that, so we can set our heat anticipators.
Okay.
So same thing. The more, to your point, as you were saying, coiling it around, we actually are creating a stronger electromagnetic field.
Sure. So what happens in a lot of our circuits, and we're going to show that here so we can prove it in the classroom. I'm actually just using, this is standard, I think this is 20, 22, 18, this is probably 22 or 24 2 speaker wire, right? Paired speaker wire. So what I'm going to do is I'm going to place this coil of speaker wire right next to my incoming high voltage. I'm going to turn my power off for a minute. And all I'm going to do now that I have my low voltage wire that is in contact with our high voltage, I'm going to go ahead and use this 579 on its standard setting. I am going to ground it because I'm looking for my reference to ground. So this is usually a good ground right here. That ground wire traces all the way back to ground in my electrical circuit. And I'm going to grab a wire here. We're just going to grab one. Let me get things out of the way here. Let's maybe set that there. So what we're going to be doing is we're now going to fire this circuit back up. And what we're going to find is we're actually going to induce some voltage onto that wire. So already, simply by bringing on power to my board, I'm already at a 0.5 volts AC. And as I start creating more of a load on my electrical circuit, I'm creating a stronger magnetic field, which is going to change the amount of voltage being applied on that wire. Remember, I'm pushing a 0.5 volt AC, doing no work besides the controls on that control board. So let's add a fan to this. Uh-oh. So I add that fan. I'm actually now up to a 0.5 volt AC that I have grabbed from our 27 watts that we're using in this particular circuit. So as technicians, when we're out in the field, sometimes we'll find these ghost voltages and maybe not know exactly where they were coming from. And so when we take the time to understand that our meter is actually reading voltage and understand where that voltage is coming from, it'll change our perspective on how we use our meters. So I'm going to shut this down real quick. Now, Louise, I'm going to go ahead and take out my 579T, turn my power off. Now, talk to me about the function of low Z or low impedance.
Yeah. So the easiest way to think about it is it's going to bleed out those ghost voltages. So basically what it's going to do is there is a resistor that is built into it that's going to bleed it out. So where it looks like it's kind of jumped those lines and you're chasing it, now it's going to put a little bit of a load onto that actual signal and it's going to bleed it out so you're not chasing it. So instead of seeing the half, you're going to start seeing, you should see it resume to the normal 0 now.
All right. So, and now I am going to need to go out of my power factor mode, correct?
Correct. And on that particular meter, it is go all the way down to the very, very bottom. So you'll see your volts, you'll see the off, and then you'll see the low Z functionality.
Okay. So I wonder, should we, on standard voltage, let's make sure that everyone sees that we are going to be measuring, if I were measuring straight volts AC, let me zoom that in a little bit. Oh, we're actually picking up even more now.
Yep.
Turn a fan on. So I'm actually picking up about 2 volts AC. And remember, I'm not generating anything. I'm simply inducing voltage from my AC line into this additional wire, which could have been a control wire. It could have been a high voltage wire that was not being energized at the moment. It could be a common. There's a variety of different wires that it could have been that we would be inducing a voltage on, going, Louise, where's this 2 volts coming from? I'm lost. And I'm so stuck now, I can't focus on my wiring diagram because I think that I've got a problem.
Want that.
Now, Clifton, we were picking up how much voltage from the other meter compared to this one?
That one was showing about 0.6.
Okay.
And it could have just been my placement of my wires. I could have been, because this is now resting a little bit more on the wires running over here, I could have picked up a little bit more.
Yeah, because ideally, really, when you put a running one, I know we're on that particular one, we're working on the voltage. But when we are doing, like when we were doing our power factor, anything we can do to make sure that we get our wires centered when we're doing our amperage will affect that reading.
Will affect that.
Yeah.
Okay. So now we're going to use this new function called low Z. Now, which meters is this low Z function on now, Louise?
So we have actually included it in all of our core meters. So our EPC, our HAC, and our DL599 all have the low Z functionality in them.
All right, there we go. So we already got one in the audience that's using the 599. So now we're going to show that same function. So maybe I was chasing this voltage and I've spent the last 2 hours trying to find where this voltage is coming from because I've got a problem in my piece of equipment, and I'm sure it's because I've got a contact bad, or I've got a coil bad, something that's giving me this additional voltage that I'm picking up on my meter. But is it real voltage? Now I can go to that low Z so that if it is just that voltage that has been applied, that's been induced on our wiring, we're going to put a small load on it and see if we can bleed that thing off. So ready to try it again?
I'm ready.
Oh, already nothing. Let's add a load on it. So it showed me that I actually did have a load that is pulled through, but I do not have voltage. So it's actually showing me that my low Z is capturing my amp draw, 0.75 amp, which is about right for my little stack motor. But I don't have voltage that's been applied on that wire like I was just reading when I was reading standard voltage. So when we start looking at troubleshooting wiring diagrams and pieces of equipment, and we think that we're chasing voltages that are partial voltages, but we can't figure out where they're coming from, that's where it becomes real important to understand, is that an actual voltage coming through, or is it an induced voltage that I've been chasing with my meter improperly? And using that low Z function on a multimeter really changes the way we become troubleshooters and service technicians.
It will truly save you a lot of time. I've heard too many stories from the field of I've spent 30 minutes, I spent 20 minutes, I spent hours trying to figure out where this voltage was coming from. And I think, that wasn't a feature though that was standard on most meters. It was a premium feature. So if you look back at your what'd you say, the DL40?
Yeah, DL40.
That DL40 that does not have that functionality in it. And really meters have made a big leap from the days of, you were talking about how many volts you were able to do on that particular meter in DC. But I don't remember all the specs of the DL40. It was before my time. But there's a lot of safety features now that are also built into those meters that weren't there in the DL40 days. There's also a lot more accuracy in them now too, because I'm gonna fairly make a good guess that I'm guessing that DL40 is a average sensing meter as opposed to a true RMS meter.
Yeah,
That's
there's no true
one of
RMS
the
rating
biggest.
on it.
Right, because we weren't worried about the true RMS as much, right? We weren't working with a lot of those inverter systems or anything like that, where that true RMS was really going to play a big feature for us as we were looking at the accuracy. So meters have come a long, long way.
Yeah. Well, I mean, I look at my 579T. I mean, that's only a year or two old. I'm true RMS, yes, but it doesn't have that low Z function. So when I'm looking at meters, particularly for the classroom, I think that low Z is an incredibly important feature to be looking for.
So there was a question that
Absolutely.
popped in, Clifton.
Yeah.
And this is Aussie 914. Does internet cables cause interference with communication wires? Ooh. I think the questioner is shielded or unshielded.
Yeah, and that does bring up an interesting. I think we're going to have to bring that in to do a little demoing to find out, because there's a lot of places that we have voltage and we have the potential for stray voltages. Even in our communicating systems, we have a lot of potential for having stray voltages on communicating wires in particularly. And we're talking about low voltages. So if I have, like say a cable, a lot of those are running on, a 5-volt DC supply, even our internet lines, and it is running parallel to a high voltage wire and it's a unshielded cable. Yeah, 100% we have that opportunity to induce some of those voltages. And I've had those scenarios before, even in residential communicating systems, where we had control wire ran in the same metallic chase as high voltage wire, and will get stray voltages and cause improper communications. So yeah, absolutely it can. That's why it's important for us to have this conversation today. All right, back to the other mic now. Any other questions out there? Because I think that's a fun demo to really look at, what's happening in the meters, and so we can actually visually see, what the meters are actually looking for. Because I would have assumed that we were able to detect that before in the past, but we're realizing we probably were not, and it's something that is new to meters that everyone really needs to understand. Cool. What do you think? Back onto a presentation now?
Yeah.
I mean, I guess. I don't know. It was so much fun. It was so much fun to make you run around at the board. I don't even know if I want to go into presentation mode.
That's
why
a
really great demo.
I'm enjoying this
video.
It has a lot of this functionality where we can dive deep. We can look at things really closely. Even when we're looking at products, I'm going to actually show you another one that I just finished setting up. So let's say we're talking about this product, right? Where is it? Well, that's one way to show, but I could also go, well, let's look at this thing, right? Now let's get back and actually talk about these settings, because those functions that I was using over there probably couldn't see as close, but now I can show you very easily. Yeah. There is our standard white letter settings. And when I need to change to my red settings, I'm using my red button to switch it over. And that's going to give me my power factor and my watts.
Yeah.
When I was looking at the low Z or low impedance, simply bringing that down. So yeah.
Yep. And then, instead of bringing up the presentation, you had the screen there. We could actually just walk around it. And I think that might be a little bit cooler than watching a PowerPoint. Unless I think everybody loves more PowerPoints, right? That's what we always say, more PowerPoints and more words on them. More words on them.
Yeah.
Paragraphs is preferable, right? That's
all right. Let's start with it.
All right. Well, that's cool.
Yeah, it gives us a very
there was
simple
a question that came in, Clifton.
I see that.
Okay.
Let's grab that. Any
Yeah.
volunteers?
Louise, want to take that one on your meter since you're familiar with the product?
Yeah. So talking specifically about our DL599, which it actually has two different features that the HAC doesn't, and that has to do with the three-phase motor rotation. So basically how that works is that it's going to take a test, and it's a multiple part test, because it's taking the L1 to the L2 and then the L1 to the L3 to make sure that they are all in the same phase rotation. Because
Okay.
it is possible on some three-phase motors that one of those phases could be out of place
Yep.
and it still runs. You're just going to wind up burning up the equipment a lot quicker when that winds up happening. So you're just and it walks you through. And there's also a video on our website, by the way, that shows somebody doing it in live time, doing that three-phase motor rotation test on I think it's on a rooftop unit that he may be working on at that point.
Very cool. That sounds like
Yeah.
sounds like an item for another day.
Yes. But that the DL599, that we've had that one for a while now. And it's been a very solid meter. The HAC, though, it has some different functionalities on it. So it doesn't have the three-phase motor rotation testing on it. But what it really does incredibly well is it is in that low amp reading, because when we start thinking about the equipment we have now, it's such a smaller amp draw that we are pulling off that equipment. It's hard for it to be accurate. So we really set a new gold standard in that accuracy when we're looking at the low amps. So this is going to make it much easier to make sure that the equipment is actually working properly, because it's so accurate through that clamp. It also, by the way, all of those meters also interact. We have an app. People love apps, right? So
Sure.
this is
Yes, they do.
not only do we have our own UEI app, the DL599 and that HAC are also integrated in the Measure Quick universe, which is a question I get asked a lot.
Yeah, I bet.
Yeah.
Well-
But let's just say the HAC for those of us in the States looks extra cool, because you might see it over there just a little bit above the screen. We debuted it in a commemorative anniversary edition. So to celebrate the nation's 250th anniversary, we have our 250 badge. Even the case has the 250 badge. And it's a limited time run. It's only going to go through until supplies last, or the end of 2026. So it's a little bit of fun. It will resume back into the original, our traditional yellow housing after the first of the year.
Awesome. While we're
right.
talking about motors, another function that I get a lot of questions on from educators is the hertz and duty capability of our meters.
Yes. So
Uh-oh. I think we're losing Louise.
I know, I was like, I froze there am I back?
Yep,
Yes,
you're
you're
back
good.
now.
All right. So hertz, that when we look at a piece of equipment, right, it will actually tell us what our hertz should be. And it's standardized here. And then you go over to, because we are an international company, right? Not all hertz are going to be the same. So we have one standard here in the US. If we went over into the UK, they're going to use a different hertz. So one, you can verify that it's actually working. But now we're working on more sophisticated equipment. And there is a functionality. Exactly. So now we're converting DC to AC. And that's your duty cycle, because it's telling you how many times that signal is going back and forth during that given second. So based on the hertz, it's going to tell you how many times it's going back and forth and give you a much better picture of how that equipment is operating.
Now, if I was reading hertz with this meter, what settings would I use, and would I be using my leads or my clamp?
So you to set up your meter on the hertz, if you see right next to that select button down there on the yep.
Right there.
Yep. You're going to want to be able to press and hold that one. And we're going to be able to see it. It may not. There we go.
So that's on the inrush side.
Yep. So that button also has the ability to do your inrush, which is going to be your amps. I think you might actually want to change your meter to volts.
Yep.
To be able to do that. There you go. There you go.
Cool.
Yep.
All right.
So you would be able to change it there, and now you're going to be able to see that. Yep.
Awesome.
Well, I don't want to miss the comment that Jim Bergman posted there, Clifton.
I can't even see my chat.
There it is, right there. So
there we go. Fantastic, Mr. Bergman. I'm glad you're joining us today. Actually, if you want to join in on the show, I can send you a link. Love to have you with us. All right. What do you think, Louise? Are we going back into our presentation, or where are we going to head to here?
You know what? I think we might as well just keep. We've already covered about a third of that dial. We might as well just keep going around.
Keep on rolling. Okay.
Yeah. Can you turn it to the upside down horseshoe for me?
The horseshoes. I love playing horseshoes.
Oh, I know, right? We might have to do that down at the farm someday.
I'm liking it.
All right. We're gonna play horseshoes. Forget bags. We're gonna play horseshoes. Okay.
Okay.
So the upside down horseshoe, also known as our ohm symbol, right? And that is a very unique spot, though, on the meter, right? Because our ohms is going to be able to tell us our resistance. But you'll note that there are 3 other symbols that are also on that particular dial. And one of those symbols that you'll note is our continuity, which is we really want to use continuity to test leads. So I know, Clifton, the meter I gave you was ready to go. But before we pull and start testing with our test leads, it's a good idea to just go ahead and check the continuity of those test leads. And you'll note, though, those 4 symbols are really designed. Those are the 4 symbols that we want to do with power off to an equipment if we are using them. And so, again, because they're in the red, we're going to be able to roll through, and we're going to be able to use that select button to roll through the different functionalities on those. So continuity, if we have good continuity, and again, this has to do with safety, when we put our test leads together, we should hear a really nice, good beep going on. If we don't have the beep, that is a good sign, one, that we want to check the connection of our test leads into the meter. And if they are securely in the meter, then, and we're still not getting that continuity beep, that is when we are going to want to go ahead and change out our test leads, because we don't want anybody injured, right? Safety first.
You bet.
One of the other functionalities, though, that you'll find on there is that you are going to find your capacitance. So now we're going to be able to test a capacitor. And it's an auto ranging meter. So you'll note to the right-hand side that it actually starts off in nanofarads. So it's also important, though, to make sure that we're paying attention to that scale that we're working with. Because when we don't have the right scale, I have seen it where somebody was measuring a capacitor, it was reading in nanofarads, and they're like, oh, and we're good. No, those are nanofarads, not microfarads. So it's important to know our scale. Right? It's very, very interesting. And then the other thing, though, that you'll find on there is the diode symbol. And we are really seeing an increase because we're diagnosing boards. And when we start looking at those, I know there's a lot of diode bridges that are put very easily in there, where people are able to test, and certain manufacturers have their step-by-step guide. But diodes weren't necessarily. The equipment is a lot more sophisticated than what it was in the past. So being able to test those diodes, make sure that we have the good connections on the board and there's not a broken path, is huge.
Yeah, I actually just got off the phone with Daikin, one of the sponsors of our mobile studio today. We're actually going to be constructing a ductless trainer inside of here. I'm going to retrofit it with all acrylic panels and test ports so that we can go through each mode. And when we get to the inverter board, we're going to do a step-by-step through the inverter board, looking at capacitors, looking at diodes. We'll have hopefully eventually a 3D diagram of what that inverter board does, so that we can walk through the entire process, so that we can verify, is our inverter board actually working properly, or are we just replacing a board for the fun of it? Being that 70% of those that come back to the manufacturer have no fault found, it's important that we understand how these meters are transitioning. So this is a meter ideal for diagnosing an inverter board.
Yeah. And so, I mean, it's if only we knew somebody who does 3D models, we might have to consult somebody. Oh, if
my
only
mind
we'll
went there too. My mind went there too.
By the way, I'm going to do a quick shout out. So I feel very lucky. We have Jim Bergman, who joined us in the chat. And I also want to call out Commercial Kitchen Chronicles that just joined us and say happy birthday, Pat.
Happy birthday,
thanks
Pat
for
family.
joining us.
I think we should sing to him.
I don't think that is a good present for me. But thought I'd give him a quick shout out. I see that he jumped on here and said hello. So, but yeah, we missed his favorite functionality. I'll let him explain that at a different time to you. But as we move along our meters, the next functionality that you're going to see on there is microamps. And so when we are starting to do, so microamps, those are so small, we're not actually going to be testing those through the amp clamp. It's the only time that you see any version of the amp on our meter that is going to be displayed on that lower display, because that lower display is really going to show you anything that's tested through the test leads. But microamps, so if we're doing flame rectification, it's such a small amount that we're looking at that we need it to be in the microamp setting.
Okay. I think we got to go do some microamp reading while we still got
all right
time on the show.
We're going to
sing. Come on, we got to sing happy birthday to Pat.
No, you don't want to hear me sing.
I'm going to. We can hit it out later.
All right, I'll let you guys sing. You guys
3,
are in.
2,
all right.
1. Happy birthday to you. Happy birthday to you. Happy birthday, dear Pat. Happy birthday to you.
Is that the first birthday time that you've gotten to sing on the show, by the way?
It is.
I
should have my video clipper here, so I can go and cut minus.
Good. It's a good thing you missed my birthday last week, Clifton.
Oh, I did too. I'm so sorry. It was kind of a crazy one last week. All right, so I'm gonna move back over. We're gonna switch microphones, and I've done an entire show on this before, but I think it's a really important one to be able to show that we can set up trainers in the classroom for teaching flame rectification without having flame. It's a very simple one, just using resistors and diodes. I show on our rectification video how to make those yourself, how to have your students make those and go through the electrical circuit so that we can show that it is a product of electricity, not heat. Thermocouples, heat. Flame rectification, do a rod, not a sensor, is a practice of voltage. All right, so I'm going to, let me switch back in. Let's get back over on those cams.
While you get set up, Clifton, there was a comment that came in about using multimeters is difficult for my students to learn properly. Yeah, going back to meter basics.
You bet.
Going back to meter basics. I mean, Louis, you could probably chime in on this too. But knowing those basic fundamentals electrical skills, like our fundamentals of your meter. The best way I tell my students to learn a electrical meter, digital multimeter, even if it's a analog meter, but specifically, we don't have too many of those around anymore, and we're going to rely on the digital, is to open up the manual and go step by step of each.
The friendly manual.
Yep, read the manual. Look at I see Lois is just shocked. Yeah, read the manual.
No, so I will tell you, so there is a version of it on the ESCO website. That is a SCORM version of what do the symbols on my meter mean? So
Yes.
as we were kind of walking around the dials, I actually have a full-on presentation that I particularly do to just even expose somebody to what all of those symbols specifically look like.
Absolutely.
But I also am available. You can reach out to ESCO. They'll get you in touch with me. I also do those in a virtual presentation. So there's things that we can do to help all of the educators out there to kind of go through that and simplify it, because I think a lot of times they just don't know what they haven't been exposed to. And
exactly
all
it.
too often, we talk about like, okay, we're going to want to look at amps, turn your meter to the big A. We want to look at volts. We're going to turn our meter to the big V that's on there. But things such as that low Z, if it hasn't come up, we haven't been trying to chase ghost voltage, or we haven't wound up with that, we're going to wind up with a student who gets a meter that doesn't know, because you don't know what you don't know.
That's exactly right. All right. I think what we're going to do here is we're going to help everyone understand the electrical circuit of flame rectification. And this is a great way to show your students. And remember, this is just a AC pad. This is a scratch and dent Goodman furnace from my local Johnstone Supply. They're happy to get rid of those to a school, by the way. Chopped everything down so that it is right in front of the student. Used our two resistors and a diode. It's a very simple circuit. So that show that in our rectification one. Have your students build this, go over the rectification diagram as you're going so they understand what we're doing, that we're going to be creating a simulated AC sine wave for the load that is happening on the flame. It is a load. That's all it is. And so we are going to be measuring it, just like Louise was saying, and it's so small we read it in micros. So if we look at what's happening, I'll show you two things real quick. To prove that it is a function of voltage, we actually have AC voltage being applied to that flame rod when it's sitting there. So when we have a display like this, where it's easy to get to, we can simply show our students, okay, how is that load happening? Well, to get a load on something, we have to apply voltage to it so we can see what we're passing through, what resistance is there. So on all of our modern ignition boards, putting our meter just on plain old volts AC, we will have from ground to that flame rod, it's typically between 40 and 80 volts AC. On some of our commercial industrial applications, I've seen higher voltages, but that's pretty typical. So we're actually applying AC voltage directly onto that rod. Doesn't have anywhere to go, right? Well, it's going to try to make its way to ground. And that's where, when we are now going to be reading microamps, the amps of our load, we can create that load. So in this particular one, we've taken our diodes, we've taken our diode and two resistors, we've created our load. I'm going to turn voltage off. We're going to use our meter in line to measure the amperage. So we're going to remove our supplied voltage. We're going to insert our meter in between it. So now our 43 volts are going to pass through our meter, and we're going to read that low amount of amperage. And so if we think about the sequence of operation, let's go through that, right? Sequence of operation, thermostat is going to come on. It's going to start our draft inducer. After a period of time, we're going to bring on our hot surface igniter. After our igniter gets to temperature, we're going to open up our gas valve. And then we're going to be looking for our load with our flame sensor. So we're just simply going to do that. We're going to fire this thing back up. We're going to put it in heat. As soon as our thermostat resets, we'll crank our temperature up a little bit. And off we go. But we have to follow our sequence. So it's great to be able to show the student that sequence of operation. If we connect early on, we're actually going to go into a fault. But if we keep our timing properly, we'll be able to create our electrical load, and the circuit board won't know any different. But we have to have a meter that is reading microamps properly. All right, so the next click's hot surface igniter. The next one will be our gas valve. All right, I can't read flame yet. I have to wait till my gas valve opens. And after my gas valve opens, introduce my load. So I am right now producing a load of 3.1 microamp that is going between this 43 volts AC and ground. So that's what we're reading with our microamp setting. We're wanting to make sure that we have sufficient flame rectification. Our AC is going to pass across the flame on its way to ground. As long as we have sufficient microamps, our circuit board is going to think it's just as happy as can be. And our control board thinks that it has flame right now. And so there are a lot of things we can do in that process, but without reading microamps, there's no way to show that student what the process actually is and what happens when our microamps are too low or too high. We can simply change out our resistors and have a variation of different loads to see where that furnace will shut down. Most of them typically drop out below 1 microamp. Just depends on the design of the board itself. And once our flame goes out, it goes out prematurely, we're going to end up going into a fault. Retry and then go into a fault. But it's super critical to understand that function of microamps and to be able to teach that in the classroom. Fun stuff.
Yes.
Speaking of teaching that in the classroom, Clifton, is make sure our students understand the concept of what 1 microamp is as well.
Yes.
Giving them, understand that it's 1/1,000,000th or 10 times negative to 6, or 10 times to the negative 6th power, right? Move the decimal over 6 places. So in this case, you said
if I had me a few thousand wines running through there.
There you go. And you were mentioning
we'll see you next
3.1?
week when you complete that.
Right.
Yeah, I'd like to see that.
I'll pass. All right. Boy, I wish my chat was working. That's crazy that your guys' chat is working and mine's not. Very interesting.
Yeah. Well, shout out to Garrett over there. It looks like he mentioned that he used the UEI meter symbol certificate on the Learning Network, and he recommends it to his students. So thank you for that. There. Yep.
Garrett's a rock star.
Excellent.
And just retiring from service to our country. So congratulations, Garrett.
Thank you for your service.
Congratulations and thank you.
Congratulations to you. Congratulations, Garrett. Congratulations to you. This has been a fun show.
You forgot to bring out your guitar for us today, Clifton. I mean, if you're going to continue the singing.
I need to. I got the foot pedal down here.
He has it.
You still have that
just
presentation?
The foot pedal, no guitar.
Thought I had 2 of them. Do what, Todd?
Yeah.
I thought, do you still have that presentation up? I thought we were going to talk about some cats.
Oh.
We got just a minute.
Yeah. So this should have been a fun question for everybody. What type of meter does a cat like to use? Anybody? It's got to be a Cat 9.
I liked it.
I love it. Very, very good slide there, Louise.
Yep.
For anyone that wants to connect with Louise on a more serious note, please get a hold of Louise at UEI. Louise, what's a good way for people to connect with UEI?
So there's a couple of great ways to be able to connect to us. So our website, ueitest.com, you can find us. We have a chat functionality that is manned by real people. We also have an 800 number, 800-547-5740, because sometimes it's just nice to talk to a real person in live time. You can email us. You'll find all of our email addresses, our info@ueitest.com, as well as I am generally not too difficult to find along the social medias. So if you do call the office, they'll get you connected to me. But we're happy to help. It's the fun part of my job. I love the training. I love giving the presentations. I love interacting with the students at AHR. Sorry, it's been a crazy travel season so far, but back at
The National
HVAC
HVAC
Excellence.
for Education Conference.
Yeah, you know that big conference that you all put on?
I know that one.
We also even unveiled a new loaner program for our combustion analyzers.
Okay.
Not all schools I know have the ability. Sometimes there's budget constraints, time constraints, things like that. So you can reach out to me and I'll be happy to give you all of the details of that program as well. But it's a nice way to be able to supplement the school program. So I was really excited to be able to launch that. But I'm not too difficult to find so long as I am actually on the ground and not flying around somewhere. But if you get a delayed response, just be patient. It's been a whirlwind of a year so far.
Yes,
And I'm loving it. Loving it.
And it looks
Well,
like Scott,
Louise-
looks like Scott liked our joke for the cat. So at least
Good. I'm sure Louise would share that slide if you just connect with her.
I love that slide. And I think cat rings are there's something that's misunderstood. We know that they're on there, but what do they really mean? So I deep dive into that a little bit more in the presentation as well for you.
Yep, very good content. I encourage everyone to connect with Louise, learn more. Louise, Todd, I'm grateful you both joined today. It's a lot of team on like this, keeps it lively and entertaining, moving, and this was very enjoyable. I hope everyone has a wonderful evening, and for any topics that you want to cover, let us know. We are adding more and more equipment onto the studio. I just came back from our sponsor iConnect last week, went up and did some measuring design to fit some new equipment on here. We're actually going to have an R290 heat pump trainer on this thing. We're going to have a full evacuation recovery charging station. We are adding tons of new things. So if there's something that you want to learn better, want to be able to be a more comfortable deliverer of content, or even just a better technician, let us know. We'll make sure that we get the right people on the show for you. All right, everyone. Well, thank you so much for joining us, and we will see you all again next week on Did You Know, the ESCO HVAC show. Bye, everybody.
Thank you.